Good morning, good evening, good afternoon, and good night to everyone watching this video on their preferable time. I'm going to do the momentum again, which is, but I'll be focusing more on the principle, which is the principle of conversation. Conversation of linear momentum. Okay, fit what we do. This principle simply states that the total linear momentum of an isolated system remains constant. Total linear momentum of an isolated system remains constant. I think this is basically the 2 marks. They are actually saying, when there are no external forces, the momentum before collision and the momentum after collision will always be equal. Scientifically, we describe this as a P before, equals to, initial and final. You'll just say initial. I'll use initial and P final. This is basically it. This is where you start, man. This is where you start. About the momentum before and after will always be equal. There isn't much to talk about there. So let's dive into the question. I will explain further when we're going to the question. So we will do question 5. We're going to do question 5. This one, question 5. I feel the diagram shows two trolleys, P and Q, held together by means of compressed ring on a flat horizontal track. Let me show you, even though the diagram doesn't really matter. They're just like making you feel comfortable because you never seen is it a car or whatever. Okay, I feel the masses of P and Q are 400 gram and 600 gram respectively. When the trolleys are released, it takes 0.3 seconds for the spring to unwind to its natural length. Damn. I feel trolley Q then moves to the right at 4 meters per second. Right, and then state the principle of linear conservation of linear momentum in weights. They said in weights because even if you write this, you write this thing, it's correct. But they said in weights. In weights, you're going to say the total linear momentum of an isolated system remains constant. But you're gonna see someone getting 0 out of 150 in physical sciences. While there are plus or minus 10 laws, which is wealthy 2 marks. I don't know whether it's witchcraft or something, but damn, we have seen a lot in high school. But don't be that, guys. Don't be that. Okay, let's dive into the business. I feel let's calculate the velocity of trolley P after the trolleys are released. After the trolleys are released. Remember, before collision, they were traveling as a unit. They were in a unit. Then no, not before collision. Before the string, the trolleys were released. They were combined by the string, by the spring, and they were a unit, a single unit. And then, okay. What we actually do here, we can see that we have the velocity of trolley Q, which is moving to the right after. But this one is, we don't know whether it's going to the right or to the left. Okay, we don't know. For now, we don't know. And then, what we can do, I think they no wait they were actually not playing nice in this question. They were actually not playing nice because most of you guys are familiar with words like rest, stationary, or whatsoever, but they didn't mention such a thing in here. But what you can basically see is that they were held together, meaning they were in one place, and then after they were released, the one moved to the right, and we don't know the direction of the other one. So basically, initially they were at rest. They were at rest. Physical sciences only needs you to think. There's nothing complicated here. You just complicate things. Okay, I'll do this as EG. I'll do this as EG and E. And then I will just come and see, okay, we have the, remember, most of you guys will be asking, why am I going to use this summation of this principle? It's because most of the times, even though you don't know the answer, most of the times in physical sciences, if they give you a law, you are certainly going to use that law when calculating. Just know, not every time, most of the times. Yes. And then summation of momentum after. Then before they were a unit, I'll just see this is the mass of P plus Q, and the velocity initial equals to VP plus MVQ. When I say MVP, it reminds me of an African, no, a vendor artist name called VP. So he's VP talking. They say he's always talking. Let's take the calculator. And guys, please note the conversion. When we move from 500 gram to kg, we basically divide by 1000. So it's look at it, 0.4. So it will be, what was the mass of 0.4 plus that one will be 0.6. You will see someone's child busy taking calculator. okay, guys, you have to know that exam is 3 hours. You won't finish, I'm telling you. Initially they were 0, and then after we're looking for the velocity of p, so it's 0.4 VP talking, okay, plus into 0.6 4. Oh damn, before you make any calculation, choose the direction. I chose east as positive because I've already indicated here as positive. East as positive, always choose the direction east as positive. And then this one is 0, and then this one is I'll take this one to the other side, so it will be 0.4 VP equals to 0.6 times 4. This is basically 2.4. It will be negative 2.4, and then VP equals to, where we're divided by 0.4. This is negative 6. So velocity is a vector quantity. It has magnitude and direction. So it's 6 meter per second left. On the question they didn't use east west, so they used right. I'll just say west. So I won't do the forces right now. I will stop here.